Okay, question 5. Show that d4y by dx to the 4 is minus 4y given this expression. So that's product rule. I do it as first differential of second plus second differential of first. So I'm going to start by writing dy dx is equal to first differential of sine is cosh plus second, which is sine, differential of first, sine differentiates to cos. Then we'll do it again, so then we get d2y by dx squared. Same process, first differential of second, which is sine, plus second differential of first, differentiate sine is regular cos. And then moving on to this term, first sine x, differential of second is minus sine x, plus second cos x, differential of first is cos x. Okay, now noticing that you've got a sine x times minus sine and a sine x times positive sine, so in fact these two things will cancel each other out, so that and that will disappear, and you've got cos x cos x and another cos x cos x, so it's the same as 2 cos x cos x. Sorry, that was my cat. Thank you. Right, now that's d2y dx squared. Let's differentiate again. So d3y by dx cubed is going to be first, so 2 cos x, differential of second is sine x, plus second cos x, differential of cos is minus sine, so it's minus 2 sine x. And then finally d4y by dx to the power of 4, first 2 cos x, differential of second, sine goes to cosh, plus second, which is sine x, differential of the first, cos goes to minus sine, sine x. And then onto this one, first, which is cos x, differential of the second, differential of minus 2 sine is minus 2 cos, and plus second, minus 2 sine x, differential of the first is sine x. Right, now we have a 2 cos x cos x and we have a minus 2 cos x cos h, so that will go with that one, and therefore d4y dx to the 4, we've got a minus 2 sine x sine x and another minus 2 sine x sine x, that's a minus 4 sine x sine x. And because that is actually y from above, that's why it's minus 4y. So there's your first, that's 5 part A. Right, 5 part B, hence find the first 3 non-zero terms. In the Maclaurin series, giving you coefficient in its simplest form. Okay, so non-zero terms, when you use the Maclaurin series, you're substituting in the value of x equals 0 into all the values. So if you put in 0 into y, you will get 0 out, because there's a sign 0 in there. If you put 0 into dy dx, you will get a 0, because sine is 0, and also sine x would be 0, so that would also give you a 0. So that one's 0, it's easy to write over here. So this gives us a 0 term. This gave us a 0 term. d2y by dx squared, well, cos of 0 and cosh of 0 are both 1, so that gives us the answer 2. That's our first non-zero, and we want the first 3. Here there's a sine and a sine, well, they're both going to be 0. In this term it's a sine and a sine, so that's going to be 0. And then you can see the pattern going on now. So if we continue the pattern, you can see d2y dx squared gives you 2 cos cosh, and then you do the same thing, cos cosh ends up being sine x sine x with a minus 4 in the gap. So the next two, so d6 y by dx to the 6, it will be sine x sine x, which would have been 0, but then it will go from the original sine x, it will become 2 times bigger, because up here the original sine x sine x became a 2 lots of cos x cos x, so it's going to be 2 lots of that, so it's going to be minus 8 cos x cos x, like that. Okay, so it's 2 lots of this one here, and 2 lots of minus 4 was minus 8. So you're going to get a minus 8. And then we know that the 7's just going to give us nothing because they're going to be mixtures. Then 8 d8y by dx to the 8 will give us a sine x sine x again. And when we go from sine x to cos x to sine x here, it's timesing by minus 2. So if you've got a cos x term, 2 terms later, you end up with a sine x term, but you're timesing by minus 2. So from here to here, you times by minus 2. So times by minus 2 will give us a 16 sine x sine x. But that will still be a 0, because there's no value when you put 0 into that. So the next one we're going to get is when we get to eventually d10y by dx to the 10, and sine x goes, it times by 2 to get to the cos x term. So from this one to this one, it was 2 times bigger, so from this one to the cos term it's going to be 2 times bigger, so it's going to give us 32 cos x cos x, and that will give us 32 when we stick in 0 into those. So most of them are 0, but the 3's non-zero coefficients will be the 2, then it'll be the minus 8, is it a minus 2 actually, hold on, yeah, 2, minus 8, and then 32. 2, minus 8, and then 32. Okay. So hence find the first 3 non-zero terms. So now we're using the Maclaurin series. Now remember, this one was on the second time of asking. So Maclaurin series would be y plus dy dx, and that will be then d2y by dx squared, and that will be y, and this will be an x next to it. This would be an x squared over 2 factorial, and then it will be d3y by dx cubed, which would be an x to the 3 over 3 factorial, and you'll be adding all these together. Now this one was the one that was a 2, so this was the d2y by dx squared, so that links to this one. So you're going to get 2x squared over 2 factorial for that one. This one was power of 6, so that will be x to the power of 6 over 6 factorial. So that's going to give you minus 8x to the 6 over 6 factorial. And then this one was to the 10, so that's going to be plus 32 x to the 10 over 10 factorial. I'll pause it there to get my calculator to put those in and simplify. That one will go anyway, so that's going to be x squared. 6 factorial is 20 times 720. 8 into 72 go 9, so it's 90th, so I think that's minus x to the 6 over 90, and then I have to get a calculator for that, so I'm just going to pause the video there.